Okay, so let's continue. All right, so now let's talk about the instance metadata. Well, the instance metadata is nothing else but the data about the data. Okay, it's just the data about your instance, right? So let me just create real quick. Let me create an instance, and in the instance, I'm going to. Can you hear? I'm not gonna connect to the instance through port 80. So I'm gonna continue here and add tag and then choose, let me choose maybe this one as one that has port 22 open. Okay. This one, no, 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 that one. Okay. So that one has port 22 open. That's perfect. And then I'm going to I'm going to SSH into the instance. Okay. Okay. So now I'm gonna bring this here. I'm gonna have my terminal. I'm gonna put it in the right side. I'm gonna put my guy here, and then I'm going to SSH into the instance. Right. So I'm gonna move. I'm gonna move to the desktop where the key is. Right. And I'm going to SSH into the instance that is already running here. Okay. So I'm going to move here and get the IP address like we did before, right? The public IP. I'm going to say SSH into, and then I'm going to just have my history. And instead of putting that IP address, I just put this one, and I just say yes, and I'm inside the instance, right? Perfect. Now, I can say curl, right? HTTP, and then say 169.254, 169.254. Okay, this is to get the metadata of any instance. Okay, but you have to be connected to the instance, right? And then I can say latest, and then metadata, and then I get all the information. Well, I get the things that I can retrieve from the data, from the instance. Okay, so here I have the AMI, right? The AMI. I can say the same thing, and now I can say AMI ID, right? Just like it says here, and I get the AMI ID. It's right here, right? You see? Um, I can say maybe one moment. Let me do something here. AMI ID, and then I say, let me try to put this inside a variable. Let's see if it works, like I do in Linux, right? AMI ID, right? And now if I say echo MID, I get the same thing. Okay, probably I have to do something else. Maybe do this. Okay. Get that information. Okay. Don't worry about that now. This is to get the AMI. It's right here. It kind of is here onto the right. Let me copy that guy. Let me copy that guy and let me see how I copy. Maybe I can do this. Nano show data or metadata. Okay. .sh. And I can put this here, right? And then do this. And then I can do ls. Show metadata is there. I can say chmod 600 or 700, and then show metadata. I can do this, show metadata, and then I get the MI here, right? This is just an executable, okay? That has it has command inside, and then I can just run the command, and I get that information, okay? So maybe here I can do yeah, print. Yeah. So you guys understand this? Now, just like I do metadata, I can say user data. Remember the user data? But this guy doesn't have anything. You see, there's nothing found there. If I had installed an Apache server, it would have shown me the information inside the user data section. When I put systemctl star HTTP D, it shows it here. Okay. So there are other things that I can get from the metadata, like the host name, for example. So I can say host name, and the host name is there. Okay, that's the host name. Instance ID, I can do that and say instance ID. And I can get the instance ID. Okay, so those are metadata is just data about the instance. Okay, and it's always gotten from this particular URL. It's the same for every single EC2 instance. It doesn't matter. You just have to be logged in the instance, right? Otherwise, it would not pick it up. Okay, that's what this guy stands for. It is for. Okay. Okay. So you can do it from the browser using the same thing, metadata, or you can do it from the terminal, and that's what we did in the terminal. Make sure that it's, you don't put HTTPS, it's HTTP. Okay? Things that you can get, all of this like we saw before, right? And you can get the user data from there too. It can be used to configure or manage a running instance. For example, author a configuration script that reads the metadata and uses it to configure applications or OS settings. That's the metadata. Okay. So CloudWatch for monitoring. Okay, you can use CloudWatch. If you come back here to my instance, let me close this guy. We're not going to use it anymore. Not for now. So I can come here to the section that says monitoring, right? Monitoring. And I can say here, whatever CloudWatch is giving me, I can see here. All right. All the instances right here. Well, all the metrics, CloudWatch metrics for this particular instance, right? So it provides a near real time. It's near real because it's not synchronously updated. It has probably some delay. Yeah, so it's not in real time completely. It provides a chart in the AWS Amazon EC2 Instance Console Monitoring tab that you can view. That's exactly this, right? Inside the instance, the monitoring tab. And this is basic monitoring. This is not enhanced monitoring. Enhanced monitoring, you have to pay for it. So this is just basic, and it doesn't have an additional cost, right? And understand, guys, that every time that you get the updates, it's every 5 minutes, right? For the basic monitoring, you get it every 5 minutes. For the detailed monitoring, it's every minute. Okay, it's something that you need to understand. All right, this is not paid. It comes with the default, configuration of the account by default, but this one you have to pay for. Okay, you can either have higher resolution metrics like every second, right? But that's something that has to be customized. Okay, the standard is 5 minutes for the basic, 1 minute for the detail. It's CloudWatch metrics. Any questions about this? No questions? I 16 students in class, none of them have a question? Okay.
Nope.
So, takeaways. Amazon EC2 enables you to run Windows and Linux version machines in the cloud. You know that already. You launch an EC2 instance from an AMI template into a VPC in your account. You can choose from many instance types. Each instance type offers different combinations of CPU, RAM, storage, and networking capabilities. You can configure security groups to allow access into instances, specify allowed ports and sources. User data enables you to specify a script to run the first time that an instance launches. Only instances that are backed by Amazon EBS can be stopped. You can use Amazon CloudWatch to capture and review metrics on EC2 instances. Okay, is that clear, guys? That clear?
Yes.
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 Thank you. So let's watch a little demo. It's just like a supplement or complement to what I did. Let's see. It's only 3 minutes.
In this demo, I'm going to set up an Elastic Compute Cloud or EC2 instance. I've already logged into the console, so I'll start by going to Compute Services and clicking EC2. And I'll click on Launch Instance. Here I can choose which operating system I'll be running on my instance. I'll scroll down to one of the Windows versions and click Select. For this demo, I'll use all the defaults and simply click Review and Launch. I can review the default settings here, but I know the defaults are fine for this demonstration, so I'll just click Launch. Connecting to the instance after it's launched requires cryptographic keys, so this pop-up is asking me to select the key pair that I'd like to use, or gives me the option to create a new key pair. I already have an existing key pair, so I'll check the Acknowledge box here and click Launch Instances. The instance is now launching and it only takes a few seconds, so I'll click View Instances and see if it's ready. This is showing all the instances I have in this region. You can see there are 2 terminated ones and a pending one, which is my new one. And there you can see the instance state has just changed to running and it's still initializing the status checks. I'll select my new running instance, and at the bottom of my screen, it shows me more information about it. You can see this new instance has a public IPv4 address and a DNS name. So let's try connecting to it with Remote Desktop. The first thing I need will be the DNS name or IP address. So I'll go to the console and copy the DNS name. The username for all the Windows instances will be administrator. And I'll click connect. Now it needs the password for the administrator account, and I can get that from the console. So I go back to the console and go to Actions and Get Windows Password. It needs my keys to decrypt the password, so I'll click Choose File, select the keys I'm using for this region, and click Decrypt Password. And here's my administrator password. I'll copy that, then back in the remote desktop session, I'll paste it in here and click OK. I'll click Yes to continue connecting. And here it is logging in for the first time as administrator and setting up my Windows desktop. I'll disconnect by closing the window, close this box. And if I no longer need this instance, I can go to Actions, Instance State, and Terminate, and click Yes. So in this demo, we've created an EC2 instance with Windows running on it, connected to that instance using remote desktop, and then terminated the instance.
Well, the good thing about this, and I see the difference between this and Linux, is that you're going to have a GUI, a graphic interface here. You're going to have your desktop, right? And you can work like an actual computer, right? But it's just a virtualized computer. It's just a virtual machine.
So I have a question.
With SSH, what we do with Mac or Linux, we don't have a graphic interface, so we cannot see anything like a computer, right? Go ahead, please.
Yeah, so I noticed that he said when he's coming out of the instance, he X'd out. Doesn't that leave it hanging where it's hard for you to get into it the next time you want to get into it? Instead of going in and doing start and logging off, he X'd out of the instance. Doesn't that cause problems when you want to go back because it's still running in the background?
No.
Okay.
You won't have any problems. As long as you open RDP port, you don't have any problems. He had to open. Did you open port? I think he did. That's a Windows computer, right?
Right, but usually, from my experiences, whenever I've noticed when I have to log users in and out of virtual machines, or what usually happens is if the user doesn't go to start, log off, or start, shut down, if they just X out of it, the VM, it leaves it hanging. So usually the system admin will have to reboot that instance for them to go in.
No, not this case.
Okay.
When you close that, the connection is closed.
Okay.
And just like I did in SSH, as soon as I just exit, right, the connection is terminated. The instance continue running, right? The instance is running. It's just a server, right? It's server. You can stop it. It's just like I did with this guy. Similar to this. This is a server, right? That is running. Right? That server is running there. It's ready for me to connect anytime I want, right? I can stop it. If I stop the server, then nothing can be connected. But your server, your virtual machine, will continue running in the background unless you stop it. But if you stop it, you have a problem. You're going to be charged for storage, okay? So here I can create this Windows, and to be honest, I'm doing something I don't like. I don't like Windows, but you know, it's a computer, right? So now here, it opens this port immediately because this is the port that allows RDP. With Linux, it opens 22, which is SSH, right? So with this guy, it's ready to be connected anytime you open the session. If what he did was log out, right? That's it. The connection is terminated. You will have to do the same thing again. It's exactly.
Well, that's what I'm saying is he didn't log out. He went in, he just clicked the X. That's what I'm getting confused at is if you click the X on the just exit out and not go start log out. It from what I understand his past experience is it doesn't log you out. It keeps it running, but it removes it from your actual vision on the computer. In order for you to successfully be able to log out, then log back in, I was told that you have to. Well, experience is you have to go to start, log off the proper way, like you do for Windows. If not, the VM, the instance stays running in the background until an admin reboots the machine.
Well, in the case of AWS, it will log you out after a while.
Okay.
After a while of inactivity.
Okay.
So
yeah.
if you clicked on the X and left it running or open, it will log you out after a while for your protection.
Okay.
And I think he. Okay. So this is the Windows computer. It's not a Linux one, it's a Windows computer. Windows Server. Okay. It's using this key. I don't have the remote control, the desktop here as my yeah. When I saw this course given by AWS for the first time, I was surprised to see that they don't give you a demonstration using Linux. They use Windows. And Windows is very it's very atypical with AWS. You know, it's more atypical. It's more typical with Azure because Azure is Microsoft. But most of the examples that people use, most of the examples, not all the examples that people use is for Linux. And the AMI that people select the most is the Linux AMI. Well, so people give demonstration. The first one that they do is this one. They use the Amazon Linux too. It's the most common AMI that people use, and therefore is the most common operating system that people use, Linux. Okay. But basically what he did is just like something that you can do so simply in Microsoft. It's like just connecting to a machine remotely using remote desktop protocol, port 3389, right? And that is very insecure. Okay, I try to use SSH, which is better, you know, instead of using RDP. I'm sorry, RDP. Okay, let me just delete this before I forget. Let me delete this image because that created a snapshot of my image, and I don't like that because I can be charged for the snapshot. So I just deleted the snapshot. Yes, guys, the demonstration was with 2 instances. I mean, one instance in one instance in Windows, and you see how he could just remotely connect to that. To be honest, it looks better in Windows because you can have a GUI, graphical user interface. You have there the desktop visual. You can use your computer. You can do whatever you want. With SSH, it's just the terminal, right? It's hard to see a computer, right? I once tried to connect my my virtual machine in Linux using VirtualBox of VMware. Tried to connect remotely, right? but it was a little difficult because there's some security measures there that don't allow you to do that. Okay, it's something that I have to investigate a little bit more. Okay, so we continue with this. By the way, I'm going to stop this. It's probably consuming resources for my computer, so I'm going to delete this. Makes my computer slower. Right. Okay. So this is the lab that you're gonna have, guys. Configuring a virtual machine that runs on EC2. That's gonna be a piece of cake for you guys. Okay. And there's not gonna be anything new here. You know, you're going to just do this with your eyes closed. You can explore the EC2 limits by simply coming to Trusted Advisor. Okay. Not only EC2, you can explore your limits anywhere, any kind of limits in Trusted Advisor, which is the cloud expert, right? It gives you recommendations for actions that you need to take, right? So you can come here to service limits, and you can see all the limits that you have in your account. You can look for EC2, and you can have EC2 here, EC2, and then you can have EC2 on-demand instances. You can have 32, right? That's the most you can have, 32 in your account. Reserved instances, you can have 20 in these regions, right? Elastic IPs, 5. VPCs, Elastic IPs, 5. So you can see all the limits. Application load balancers, you can have well, it says that my current users might differ. Okay. No specifics here, but maybe you can have, how many groups can you have? 300 groups, IAM groups. You can have users, IAM users, you can have up to 5,000, right? You can have IAM roles, you can have up to 1,000. So, bottom line, guys, you can have a check of your email, of your services limits here in Trusted Advisor, right? That's the place. So at the end of the lab, this is going to be your complete product. Right? We're going to have 2 instances. They're going to have 2 volumes. One has 8 gigabytes, one that has 10 gigabytes. You're going to have security group. You're going to have a VPC. That's it. That's going to be your final product. Lab 3. Well, that's the okay, and you're going to do that to some work as well. So this is something that maybe we can do in another class, right? Because you don't have time for this. But maybe you can answer the questions that come in next. Okay. So between Amazon EC2 or Amazon RDS, which provides a managed service? What do you think? My question for you is, first, before you do anything, do you know the difference between managed and unmanaged? No?
We said manage is that Amazon is managing the infrastructure instead of your...
They own the line infrastructure, correct. And that's managed. And unmanaged is us. So it means that we have to manage it, right? Now, we said that EC2 is infrastructure as a service, right? We saw that before. What do you think about that? Is that managed or unmanaged?
That is managed.
Are you sure?
Managed?
Yes, they're all managed services. Isn't that all Amazon offers? Managed services. It's a level of management.
Okay, what do you mean by automatic services?
No, I said that's all Amazon offers. Managed services is just the level of which the management exists.
The managed one here is EC2 because RDS is just you are the one determining the engine, and then you have to install that engine in an instance, right?
Wait, can you rephrase that again? Can you say that again?
I mean, RDS is relational database service, right?
Correct.
So, as part of that service, right, you're basically determining you're controlling the database engine, but where it is installed is something you have to install your engine somewhere, right? Your database server, I guess.
Not correct. You don't install any engine in RDS. RDS already had it. It has it already. You have to choose the one that you want, and it's there already. Right? So that makes Amazon RDS a managed service. You don't have to take care of any underlying infrastructure, no database patching, nothing is done by you for you. Right? EC2, the first thing that you have to do is choose the operating system. Right? So you have control on the operating system. You don't have control on the operating system of RDS. You don't choose the operating system. EC2, you have to patch it. You have to maintain it. You have to upgrade the operating system if you want to upgrade it. You have to install softwares. You have to install the servers, right? Because it doesn't come with it. That makes EC2 an unmanaged service. Infrastructure as a service is never managed, right? EC2 is managed by you. AWS gives you all the resources. You're the one that has to configure it. You're the one that has to do all the things, right? Inside that. Now, AWS will provide the operating system for you. You choose it, right? You don't provide the operating system. Now, if you want to upgrade it, then you have to download it, right? You have to do the maintenance, the patching, the upgrading, the provisioning. Everything has to be done by you, right? But it's not that bad either, you know. It's not something, you just have to work with it, right? Let's do something. Let's do something real quick, right? So let me create an EC2 instance, because you can have an RDS database, right? And you can have an EC2 instance with an engine inside. There are two ways to host a database in Amazon, in AWS. Two ways to store to host a database. One is with RDS, which is very simple, right? It's very simple. You just choose the engine, configure it, and that's it. Done. But sometimes you want to use EC2 and install the engine. EC2 doesn't come with the engine. You have to install it, right? That's another way. The problem with EC2 is that you have to do a lot of work. You have to do the provisioning. You have to do the patching, maintaining all that. With RDS, you don't have to do it. The result is the same. You're going to host a database, but the overhead is different. Okay? Let me see if I can create an EC2 instance, right? Real quick. So I'm going to create this guy here. And then I'm gonna create here, give it a public IP. Right? That's fine. Storage is fine. Security group. Okay, let me say here, name, database. Right? Now I'm going to create a group. I'm gonna call it my MySQL DB security group. Right. I'm gonna leave SSH there because I have to log into the instance. I'm gonna open another one, and this is gonna be MySQL Aurora. I'm gonna open port 3306 just in case I want to connect. And here I'm gonna use my IP. Right. Review and launch. Right. Launch. I'm gonna use this Saturday key pair. Okay. Perfect. Okay. So let's wait for that to be ready. Okay, it's running. It's running already ready. Okay. So now I'm going to SSH into this guy, right? Like I did before. I'm gonna grab this IP address. And then I'm going to SSH into, I always have to move where the key is. It's in the desktop, right? And then I say SSH. I have the history here. So I'm gonna use this IP address and connect to my instance. Say yes. Good. I'm inside the instance right now. Okay. So the first thing that I'm gonna do is become a root user, right? Sudo I. Become a user and say yum install wget. Okay. It's already there. Good. Now I'm going to install MySQL yum repository. Okay. So I'm going to copy this here. I installed already. Okay. Now I'm going to install MySQL locally. Install, say yes, and then complete. Right. Now I'm going to install my MySQL community server. Right. Okay. Okay. Install this. Yes. Okay. So installing that. Yes. So installing that. So I'm installing all this. You see how much I have to do here? Right? If I have an RDS, I don't have to do any of this. Right? So it's a lot of overhead here. See? It's just installing this, and we continue here in the meantime. Okay. So the answer for this is Amazon RDS provides a managed service. Amazon RDS handles provisioning installation and patching, automatic backups, restoring snapshots from point in time, high availability, and monitoring. All of that is provided by RDS. Okay. You don't have any of that. Most of the things that you see here, you don't have them with EC2. Okay. So what could be an advantage of deploying Microsoft SQL Server on an Amazon EC2 instead of Amazon RDS? Just think about it. What could be one advantage? At least one. Right? What you see that I'm installing this here, but there's an advantage, right?
You can install a version that you want.
Correct. I have control, right? I have control, and that's a good thing, right? Now I can say service MySQL D status, right? Right now it's inactive, right? So it says system CTL enable MySQL D, right? And now I can say system CTL start MySQL D, right? And now if I check the status, I see it's running. So my service is running now. Okay, so now I can say, just give me 1 second, because this one doesn't have a password. Okay, so I can say maybe grep and then temporary password, right? From var log MySQL D dot log. Okay, let me move this a little bit more. So I have the SQL password here, right? And now I can say MySQL U root, that's the user, root P password, and enter this password, this weird password here, so I can reset it later. It doesn't echo the password, so it's hard to know if I'm inside. So now I'm inside. It says Oracle is registered trademark. Now I can do something here and do some like change the password if I want to. Okay. Like maybe I want to reset the password. Okay. So now I don't want to reset the password now. So what I can do here is check. I can say show databases. Show databases. And this is SQL already. Marjorie set to password. Okay. I do that now. Okay. One moment. So I say this. I would say this alter user, right? And then root at localhost. You see how much overhead I have to have here? Identify, right? And then by on my password. So I'm gonna say this. You guys can see it. This is local. It doesn't matter, right? And that is a problem because I forgot to put the semicolon at the end. That's why this is what happens. So I do this, and I paste this, and I put the semicolon, and then, okay, perfect. Now I can do this. So I could reset the password, and now I can say show databases. Okay, and it shows me the databases, right? Now I can create a database, create database, and say Saturday class. Right? Oh, I forgot again. Right. So now I can say show databases again. I can do up arrow, and then I get here Saturday class, right? And then I can say here probably use MySQL. This is one of the databases. So I'm going to use that one. Use MySQL, and now I can say show tables, and it shows me all the tables. Okay. Right. So now it would be nice. It would be nice to connect this to dbeaver. Okay. So probably I can come here and use dbeaver and create a new database here. So I can create all the tables and things from here. So I can come here to MySQL, then next, and put here localhost. It's not localhost. It has let me come here and see if I can find the host here. Maybe I can use the DNS, the public DNS, right? And then I can put here this guy. Right? Database is going to be Saturday class. Right? The username is going to be root. And then this one mouse. Okay, root, and then let me use the password that I selected there. Let me see if it connects. Okay. Message from the server host. Speed is not allowed to connect to this MySQL server. Okay. Yeah, this is the problem that I'm coming with. I come here, Sport A3306. Well, probably if I change the security group of this guy, you know, so I can come here, security group, and maybe I'm getting this guy here. So probably here, selecting probably. Okay. Oh. I don't know if that's going to make a difference. No, I'm getting that. Let me say, instead of grabbing this guy, let me see if I can grab the IP address. So there's some issues there that is preventing me from connecting. So here, root, and then say password locally. Let me just type the password again. Yeah, it's not letting me do it, guys. Yeah, that's something that I have to research a little bit more, because for some reason there's something blocking me that is not letting me connect. I am connected. I have my server running here. Okay, I have my server running. So probably I can create a table and say, okay, one moment. Create a table here and say table users, and then probably this, and say user ID, right? User ID. And then we can say int primary key, auto increment, right? And then username. It's going to be a text, and then it's going to be not null, right? Users. Oh, I have two user IDs here. Should be one. ID int primary key auto increment, and then text not null. Oh, I didn't leave a space between not null and text. Good. So now I have my table, right? So if I just show tables, I have my tables users here, right? Let me use Saturday class, right? And then let me create that table there. Create a table, and I'm going to say insert into users. I'm just going to put data there, users, and then we're going to say username, values, and I'm going to say Dunieski, right? Close that. One row affected. I guess I show tables. It shows me the table users, and then I say select star from users, and it shows me. Oh, I forgot. I always forget this. And it shows me user ID 1, username Dunieski. So I can create this. It's working. My server is working. So I have a database server running in my instance, right? And you guys, you see how we can do it, right? The only thing that we need to do now is to connect to a GUI, right? Like a bench, like Workbench or probably dbeaver. So with dbeaver, this is my local MySQL database. So I don't know. I have to check this out. Why I'm not able to connect to this one, right? Maybe what if I change this to localhost instead of doing that? Let me see. And now if I do this, connection refused. So I have to take a look at this, right, and see what happens. What's going on here, all right? But it is working in my server. So you guys understand what I did here?
Yes.
Yes. I have right now 15 students in class. Do you guys see what I did in an EC2 instance?
Yes.
Okay. So I can create tables. I can show tables. I can do whatever I want with tables. I can even change the headings here by saying select user ID as user using an alias and user name as user name. There you go. I changed it using an alias, right? Right? I can create another user and it will say, now let me say, and say Janet, right? Create another user and say Fernando. I create another user and say Carlos. And now, if I just print this, I get 4. Okay? So this auto increment thing that I created when I created the table, right? This auto increment thing will increment the ID one by one. Okay? Beautiful, right? It's beautiful. So it will be nice to connect it to a GUI so I can see it better here. I can work and just print whatever I want, just like this. Print it here, right? It doesn't print because I stopped the server. Remember, I stopped the server to save on consuming, on resources. So it's not working. Hey guys, that's the way it is, right? That's the way it is. You want to create another table. You choose here, instead of using users, let's say orders, right? Orders. Right? Right? And then you say order ID, right? And we say key or increment, and we say order total, right? And that's going to be, let's say, numeric 18,2, nano, and then we can say user ID, int nano, right? Okay, so I have another table. I would say, well, I should have done something different here. All right, not a problem. So I say show tables. I have 2 tables. Okay. Let me just drop the table. Dot table orders. Okay, gone. Let me create it again. But now I'm going to say user ID, a foreign key. Foreign key. User ID. Right? References. Users. User ID. Right? And then we say on delete cascade. Right? On update cascade. Good, right? So now I can say insert into orders, and we say total 299.99, and then user ID 1. Or actually is order total and user ID. And then I can say values 299.99, 1, 344.9, 2. Okay. Two duplicates. Okay. Okay, not a problem. So now I can say, select everything, right, from users in a join, orders on user ID, well, user ID equals orders user ID. And I bring the two tables together. You see? I can do anything I want. This is SQL, guys. If you don't know about SQL, well, try to bear with me. I'll just show you that I can do anything when I have this guy installed. All right. So I have two tables, and then I bring the two tables with the primary key and the foreign key right here. The foreign key that refers to the user ID of the other table. And then I can bring the two tables together by using an inner join that joins one table with the other. And I say the user ID, bring me everything when the user ID in the table's user is the same as the user ID in the table's order. That's why I got these two values. Guys, now I could have said something like left join and preserve the left side and bring the guys that don't have anything. Okay. Well, a mini lesson on SQL. Okay. Interesting, guys, right?
Yes.
Yes.
Okay. And the good thing about this and the impressive thing about this is it is inside an EC2 instance. That's the thing that really, it's impressive here. Right. So let's continue. I will leave it running because I want to find a way to install it to connect it to the Beaver or Workbench, either one, doesn't matter. Right? So let's continue here. So one of the advantages of this is that you have control. Okay, you have control over the configuration, the OS, the software stack, all the things, right? What advantages does Quick Start provide over a manual installation of EC2? Well, I can tell you the Quick Start gives you the guides, right? And it also has the template to do it without doing it manually, okay? Quick Start is a section in AWS where you have a lot of templates and things like the one that I showed you this morning to install a Bastion host, okay? Okay, so this is the Quick Start here that, you know, you can install so many things here to start quick. That's the you know, Quick Start here. And you have a lot of things here. Then you can see the deployment guide, right, for the Bastion host. And then it will provide you with the template, right, with the template to create that resource without doing anything manual. It's all CloudFormation, okay? It's a template in YAML. Okay. Good. That's the Quick Start. Template YAML is this one. Similar. Okay, so we start surfing architecture with proven best practices built into the design. Which deployment option offers the best approach for all use cases? Well, neither. The correct deployment option depends on your specific needs. Okay. The next question is, which approach costs more using Amazon EC2? Well, EC2 RDS, well, it depends. It depends. Managing the database deployment on Amazon EC2 requires more customer oversight and time. You saw, guys, what I had to do, how many things I had to do because I was doing it in an EC2 instance, right? If time is a priority, then you have to use RDS. That will be less expensive, you know, and it's going to be faster. If you have an in-house expertise, Amazon EC2 might be most cost effective. So, I mean, it depends. It depends. Everything depends, right? Okay. Cost optimization in Amazon EC2. Well, we have several pricing models that you can think about when it comes to Amazon EC2. The first one that we see here is on-demand instances. Okay. Now, on-demand instances, they are you know, cost effective, right? But you're going to be paid by the hour. You're going to be paying by the hour. Okay. Now, paying per second, paying by the second, is available only on demand instances, reserved instances, and spot instances that are run on an Amazon Linux or Ubuntu machine. Okay. That's per second billing. Okay. Only for Amazon Linux and Ubuntu. The rest of them is per hour. So if you run these instances on an Ubuntu or Amazon Linux machine, then you're going to be billed by second. And the thing about this is that if you run the instance for 2 seconds, you're going to be billed for 60 seconds. The mandatory time to run an instance is at least 60 seconds. You're going to be charged for 60 seconds no matter what. If you run it for 3 seconds, 4 seconds, 10 seconds, 59 seconds, you're going to be charged for 60 seconds. After that, you start being billed by second. But the first 60 seconds, you're going to be billed by them. Doesn't matter how long you run it. Okay. With all demand, there's no long-term commitments. The commitments are for the reserved instances, right? But this is a balance, right? This is a balance. You reserve for 1 year or 3 years, but you're going to save more money, right? So that's when we come to the reserved instances. And of course, this is eligible for the free tier, okay? Reserved instances, you can have full upfront, partial upfront, or no upfront at all, okay? So there are 3 ways that you can reserve instances. And the terms are 1 year and 3 years. Full upfront, partial upfront, no upfront at all. Okay. You get a discount on hourly charge for that instance, right? You also have dedicated hosts, right? Which are servers, right? Physical server with EC2 instances, capacity fully dedicated to your use, okay? So a dedicated host is a big server with many EC2 instances that are dedicated for you. So we can see a dedicated host as a hotel, right? As a hotel, and the dedicated instances just below, dedicated instances as the room of the hotel, okay? So the dedicated host is a server that has EC2 instances, right? Capacity dedicated for you. And then a dedicated instance is just the instance that runs in a VPC on hardware that is dedicated to a single customer, okay? Why? Because this instance here, they run on, with other instances from other customers on the same hardware, right? That's why they have a shared tenancy. So they are on the same hardware, okay? It's not only one hardware. There are many pieces of hardware, but they're shared. Dedicated instance is only for you. And that's pretty common for governmental institutions, organizations. Okay. You also have the schedule reserved instances. Those are the instances that you may, stop or start at a specific time, right? On a recurring schedule, you can specify. It's purchase a capacity reservation that is always available on a recurring schedule you specify, and that's for 1 year. Okay. So reserved instances, just plain reserved instances is 1 year or 3 years. Scheduled instances is 1 year. So you only pay for the time that the instances are scheduled, even if you do not use them. So you pay for 1 year, you have to use them. If you schedule a specific time, you're going to pay for that, even if you don't use them. Okay. Spot instances, very atypical way of AWS bidding on auctions, instances. This is an auction, right? You bid on it, you're the highest bidder, you get it, right? But if someone outbids you, you lose it. So that's the way it is. Okay. Well, if you think about eBay, it's a completely different concept, because in eBay, you bid on something, you're the winner, you get it, it's yours. Not in AWS. You bid on that, right? Because this is a spare capacity that AWS has. You bid on that, you get it, it's yours. Someone outbids you, you lose it. You have 2 minutes to do something about it. So AWS is going to give you 2 minutes notification. You have a 2-minute window to do something, to pay more and outbid the highest bidder, or to just withdraw and say, I don't want it anymore. But you have to do something about it, because, if you have critical information, critical data there, you will lose it if you don't do something about it. Okay? So AWS can just interrupt it, terminate it, stop it, hibernate it. I don't know. They can do something about it. And you can save up to 90% compared to on-demand instances. Okay, up to 90% you can save. Okay, they are cheaper, but the problem is that you're always on stressed out, because if you buy this for testing or something, you lose them, doesn't matter. But if you buy them, you want to save money, and you buy them for something important, well, you better be careful. You may lose them, right? Now, this is also for, flexible start and end times. You can stop it and end it anytime you want, right? And, it's good when you have flexibility and when you want the application to run. So that's the way. So we have on-demand, dedicated hosts, dedicated instances, reserved instances, 1 to 3 years, a schedule reserved instances, 1 year, and spot instances. You can save up to 90% compared to on-demand instances. Let's see some benefits here. For on-demand instances, there is low cost and flexibility, right? Well, on-demand, we're gonna see the use cases after this slide. Okay, so we say here is on-demand. Whenever it's needed, it's gonna be there. Also on-demand. Spot instances is for large-scale dynamic workloads. Okay, so think about this, guys. Learn this, because this might show in the form of a question in the exam. Okay. Well, when things are predictable, you see here it goes up and then stays there forever. Then you can reserve instances, right? And this predictability just ensure that the capacity is going to be there when needed. Okay. And you see this lock here, it means that is dedicated to you only. And it saves you money on licensing costs, because you can bring in license as well. And it can help meet compliance and regulatory requirements. It's dedicated, guys. It's only for you. Okay. Let's see some of the use cases here. Okay. Well, this is for spiky workloads. Okay, spiky workloads, short-term, spiky, and unpredictable workloads. Okay, let's say that It is not throughout the year when the traffic is good in your company, but let's say that for Thanksgiving next week, for example, your company is going to have a lot of traffic, a lot of requests. So what do? You use on-demand instances, right? Okay.
Can you exceed the reserved instance and then you kind of go from that to say like an on-demand?
Yes. Yes, you can have a combination of them.
Okay.
Yeah, you can have a combination of them. You not only reserve, you can have reserved, you can have on-demand, you can have spot, all of them at the same time. I'm played with that. So an architect will explain to you how to use them. Okay. The company. So spot instances, like I said, has flexible start and end times, right? You can, I mean, this could be in the form of a question exam. The company is looking for instances that have flexible start and end times. They're not going to tell you spot, but you have to think that they're talking about spot instances. Right? Applications only feasible at very low compute prices. You know, they're saving a lot of money with this guy. Okay. Now, on-demand is application development or testing, right? You can use this one for testing too. Users with urgent computing needs for large amounts of additional capacity. So if you have a lot of instances, but you need more capacity, you know, additional capacity, you can use spot instances is the best instance for that. Okay. Now, reserved instances is for steady state or predictable workloads. It's just the opposite of the on-demand instances. On-demand instances is unpredicted. Reserved instances is predicted. Applications that require reserved capacity, including disaster recovery. And users able to make upfront payments to reduce total compute costs even further. Guys, this is just like buying a house, right? It's like purchasing a house. But for a house, I wouldn't say a house because the house you always have to pay upfront. You have to give payment and a down payment. But for a car, you have the option of not paying down payment. Of course, your payments are going to be higher, but you have that choice, right? The more you pay in down payments, the slower your monthly installments are going to be, right? So that's how it works for reserved instances, right? So let's say that you don't want to use them anymore. You can sell them in the AWS marketplace, right? It's just like a lease, a car lease, right? If you don't want that car, you have to find someone that will take on the lease, right? For you. So they will purchase the car, right? Same thing here, right? The only difference is that you're going to be charged like 25% of the upfront fee if you just decide not to use them anymore. Remember, you have a contract. Don't forget that. For dedicated hosts is for highly sensitive workloads, right? You bring your own license just in case it is, a license of a dedicated host or something, or like a Windows computer, Windows license. Okay. Compliance and regulatory refrigerant usage and licensing tracking and control instance placement. Okay. So you can place the instance whenever you want, any type of placement groups you want. Remember, this is dedicated to you only. I mean, you're paying good money for this. You deserve to have whatever you want. But money first. And don't forget that time is monkey. All right, let's continue. The 4 pillars of cost optimization. So this is very important too. The right size. You always have to choose the right size of your compute services, right? You have to see that it has increased elasticity. You have to see that there's an optimal pricing model. You have to choose which one is the best for you. If it is on-demand, reserved, dedicated, spot instances, and you have to choose the correct storage choice, okay? How much capacity you need. So let's talk about each of them one by one, okay? So the right size, okay? Well, you need to see how much CPU you need, how much memory, storage, network throughput, okay? and then you go ahead and select the appropriate instance type for your instance. Okay, so we can come back to this guy and, you know, think about your EC2 instance, right? When you launch it, then you select the AMI, then you have to consider what are your needs, right? What are your needs here, right? What type of instance type do you need? Okay, you have here a lot of instance types that you can choose from, right? How much CPU do you need? How much memory do you need? How much network performance do you need? Okay. Also, use Amazon CloudWatch metrics, how idle are instances, right? When they're idle, and then downsize instances. It means just, you know, if they're idle, it means that they have extra capacity, right? You don't need that much capacity. So what you have to do is just downsize it, choose a lower instance type. Okay, so maybe you have T2 large, then go down and scale down to T2 medium or T2 small. Okay, so that's what it says. Okay, and CloudWatch will tell you if your instance is just idle. If I go now to my instance, it shouldn't be idle because I have this MySQL server running. So let me take a look at that, the monitoring section on my instance. So I come here and take a look at my instance, the monitoring section. Let me move this a little bit to the left. Okay, maybe this one to be able to see a little bit more. So I'm gonna come here to the monitoring section, and I see here that I have some CPU utilization here, right? Okay, and this is exactly my server running because I have a SQL server running here. All right. So if you see there's nothing here, and you have traffic coming into your instances, right? It means that your capacity is not the correct one. So your size is not the correct one. Downsize, please. That's going to help you. Okay. Okay. So best practice, right size, then reserve. Okay. The more we reserve, one of the pricing models of AWS is you pay less when you reserve more. Okay. Increase elasticity, stop or hibernate your Amazon EBS backtop instance, right? Okay. Example, non-production development or test instances, okay? I mean, when you stop it, you're gonna save costs, right? But you're gonna be charged still for storage, okay? So stopping helps you save money, but it's not like you're not gonna pay anything, okay? It's just that you need that instance, but you don't need it to run when you're not using it, okay? You're still gonna be charged for storage. Using automatic scaling to match needs based on usage, right? You want to use automatic scaling to scale out, scale in, right? And that's gonna be automated. Okay. Guys, why don't we take a 5 minutes break? How about that? Do you like the idea?
Yeah.
Yes, please.
So let's take a break. Let's be back here at 3:01.
Okay.
Okay, let's continue. So optimal pricing model will leverage the right sizing model for your use case. Consider your user patterns. Optimize and combine purchase types. That's exactly the question that they asked me. You know, if you can use several things together. Well, use on-demand instance, spot instance for variable workloads. I use reserved instance for predictable workloads. Okay, so you can have a combination of all of them. And also consider serviceless solutions like AWS Lambda. Okay, that's something that you're gonna have a lot of peace of mind. You don't have to work so much with AWS Lambda. Well, when it comes to optimize the storage choices, reduce the cost while maintaining storage performance and availability. Resize EVS volumes. So you have general purpose or throughput optimized, and then you can go ahead and just choose something, something cheaper. They give an example there. You're using general purpose SSD, GP2, right? And then you can use throughput optimized HDD, SD1, which is probably 50% off general purpose SSD. Of course, the performance is not going to be the same, right? Because SSD is much more excellent than HDD. You can delete all the snapshots that you have because you don't need those guys. Delete them. You're going to be charged for that. So delete them. Then you have to decide where you want to store the data, if it is EBS or an S3 bucket. Okay. So it's your choice. You have to think about it. And then, S3 has something called lifecycle policies, where you can move the objects from one place to the other based on age. So after 30 days, you move it to one class. After 60 days, you move it to another class. And after 90 days, you move it to Glacier. When we talk about storage next class, right? Then, and by the way, stay tuned, because I think that there's no classes next Saturday. So I keep you posted, okay? So we're gonna see, when we see storages, like the life cycle policies, okay? Measure, monitor, and improve, right? Cost optimization is an ongoing process, right? It's very important, guys, that you enforce tag using. So tagging is important. Why? Because when you want to identify your resources, tagging has a major role to find the resources, okay? And that's gonna save you on cost, right? So define metrics, set targets, review regularly, have budgets, right? Always encourage people to think about cost when they build something. Cost is very important. Assign the responsibility of optimization to an individual or to a team. Guys, when you do something, always think about money and cost. Look for the best solution, but save on cost. The most cost-efficient, best solution. Okay? Be careful in the exam, because they're going to tell you the most cost-efficient solution. They may have 4 solutions that are possible, but let's look for the most cost-effective solution. Your takeaways here: EC2 pricing model, include on-demand instances, reserved instances, spot instances, dedicated instances, and dedicated hosts. Those are the pricing models. Spot instances can be interrupted with a 2-minute notification. However, they can offer significant cost savings over on-demand instances. The 4 pillars of cost optimization are right size, increase elasticity, optimal pricing model, and optimize storage choices. If you want to save cost, when you use using EC2 instances, this is the way. Let's talk about containers. Okay. Well, containers are a method of operating system virtualization. Right? So a container contains everything that your application needs to run. Okay. It contains all the dependency, configuration, hooks on into the OS operating system. What is the benefits? Repeatable, self-contained execution environments. They're self-contained. That's something that it's very typical in containers. They're self-contained. They don't depend on other containers, right? And you can run instances on containers, right? So software runs the same in different environments, developer's laptop, test, production, anywhere, right? And it's faster to launch and stop or terminate than virtual machines, okay? Well, the service is ECS, right? It's ECS, Elastic Container Service. It also has Docker. Docker is super popular right now, super popular. So Docker is a software platform that enables you to build, test, and deploy applications quickly. So you run containers on Docker. Containers are created from a template called image. Okay, you have an image, right? That you can store in ECR, Elastic Container Registry. Okay? And a container has everything a software application needs to run. That's what I said before. All of these guys here. Right? So it has all the libraries, system tools, code, runtime, everything that you need to run an application. So when you want to use a standardized environment, reduce conflicts between language stacks and versions, use containers as a service, run microservices using standardized code deployments, require portability for data processing, you can use Docker. Okay, that's the guy, Docker. You're never going to have any conflict between languages, and you can use many languages, right? With Docker, you don't have a conflict with languages. Now, many people who are first introduced to the concept of containers think that containers are exactly like virtual machines. However, the differences are in the details. One significant difference is that virtual machines run directly on the hypervisor, right? But containers can run on any Linux OS if they have the appropriate kernel feature support and the Docker daemon is present. This makes containers very portable. Your laptop, your virtual machine, your EC2 instance, and your bare metal server are all potential hosts where you can run a container. So the right of the diagram has a virtual machine, right? Deployment. Each of the 3 EC2 instances runs directly on the hypervisor that is provided by the AWS global infrastructure. Each EC2 instance runs a virtual machine. In this VM-based deployment, each of the 3 apps runs on its own virtual machine, which provides process isolation. The left side of the diagram has a container-based deployment, right? There is only one EC2 instance that runs a virtual machine, right? There's only one, and the Docker engine is installed on the Linux guest operating system of the EC2 instance, right? And there are 3 containers. In this container-based deployment, each app runs in its own container, which provides process isolation, but all the containers run on a single EC2 instance. So the processes that run in the containers communicate directly to the kernel in the Linux guest operating system and are largely unaware of the container's silo. So the Docker engine is present to manage how the containers run on the Linux guest operating system. And it also provides essential management functions throughout the container lifecycle. So in an actual container-based deployment, a large EC2 instance could run hundreds of containers. You see? So that's crazy. I mean, here you have 3 EC2 instances. Here you have only 1. And then on top of that, you have the Docker engine. And with the Docker engine, you can run different containers. And every container has an application. You see the difference? So if you're going to choose between this one and this one, well, guys, I don't think that we have to think about it twice before choosing Docker. Okay. So Elastic Container Service, it's highly scalable, fast container management service. Right? The key benefits, orchestrates the execution of Docker containers, right? Maintains and scales the fleet of nodes that run your containers, removes the complexity of standing up the infrastructure, is integrated with features that are familiar to Amazon EC2 service users, like Elastic Load Balancing, Amazon EC2 groups, EBS volumes, IAM roles. So containers work with everything that we need or that we've seen so far. Here we have the example how they orchestrate this. Okay. So we have the container service here, Elastic service. We have container A, container B, right? And then you have the EC2 instances here, right? And the ECS cluster, because you have to get a cluster that has a bunch of EC2 instances. Question, do you want to manage the ECS cluster that runs the container? If yes, create ECS cluster backed by Amazon EC2. It provides granular control over infrastructure. If no, then create an Amazon ECS cluster backed by AWS Fargate, easier to maintain, focus on applications. So Fargate is serverless. That's why it's easy to maintain, and you don't have to focus on servers, but focus on the application. Okay. So back to Amazon EC2, you have to manage all this, right? All this. Back to Fargate, you manage only the libraries and the applications. AWS manages the other thing. Okay. Remember, this is serverless, and this is with servers. Okay. More expensive than EC2 for sure. What is Kubernetes? It's an open source software for container orchestration. Guys, Kubernetes is for the development certification, the DevOps certification. For this one, it's only to get an idea, right? Don't stress on this. Just know that there's a service in AWS known as EKS, Elastic Kubernetes Service. And what it does is it supports Kubernetes, right? And it complements Docker, right? This Kubernetes complements Docker, right? It automates the provisioning container, networking, load distribution, scaling. And Kubernetes is not an AWS service. It's a third-party service, like Docker. It's a third-party service. What really matters is that we have this guy that supports Kubernetes. It enables you to run Kubernetes on AWS. It has the certified Kubernetes conformant, supports easy migration, and then supports Linux and Windows containers, compatible with Kubernetes community tools, and supports popular Kubernetes add-ons. Use Amazon EKS to manage clusters, Amazon EC2 compute instances, and run containers that are orchestrated by Kubernetes on those instances. Okay. So need to know what Kubernetes is, and the Amazon, the AWS supports Kubernetes. Well, this is basically the guide that you can store, manage, and deploy Docker container images. Okay, so if you want to just save them in a place, that will be the registry. You can come here to Docker Hub, and then you can just download the image from there. Okay, it says here, you can put here image Linux, for example, and it gives you Ubuntu, Alpine, all these images here. Okay, and you can save those images in ECR, and then you can bring them from there when you're going to run containers. Okay, Docker containers, basically. Okay. So you will have to create a repository, and then in the repository, you will store those images, right? And then you can create a repository, right? And then you can put those images there. Has Amazon ECS integration, Docker support, team collaboration, access control, third-party integrations. Takeaways: containers can hold everything that an application needs to run. Docker is a software platform that packages software into containers. A single application can span multiple containers. Amazon Elastic Container Service, Amazon ECS, orchestrates the execution of Docker containers. Kubernetes is open source software for containers orchestration. Amazon Elastic Kubernetes Service, Amazon EKS, enables you to run Kubernetes on AWS. And Amazon Elastic Container Registry, Amazon ECR, enables you to store, manage, deploy your Docker containers. Right. Okay, let's talk about Lambda now. Well, Lambda is a serverless compute service. That's all you need to know with this guy. That summarizes everything in Lambda, right? So you love your code in your computer, and the code you run is a Lambda function, right? Then Lambda function can do something when the code is just uploaded, right? You know, and then the code is run on a schedule or in response to events. Okay? You can request services from a mobile device, from an endpoint, AWS services, and then Lambda will do something about it. Okay? Then, when the code is run is when it is triggered. Otherwise, it won't run like a function, right? And you only pay for the compute time that you use. Okay. What are the benefits of Lambda? Well, it supports multiple programming languages, right? Completely automated administration, built-in fault tolerance. It supports the orchestration of multiple functions and per-use pricing. So you come here to Lambda, and then you say, I'm going to create a function, right? And then I'm going to say, I want to choose the runtime. So I can choose .NET, Go, Java, Node.js, Python, Ruby, right? So those are the languages that you can use with Lambda. Well, event sources, some of the things that can cause an event is Amazon S3, DynamoDB, SNS, SQS, API Gateway, Elastic Load Balancer, and many more that will cause Lambda to do something, right? Execution of the code, only when triggered. You can have logging and metrics with Amazon CloudWatch, okay? You can invoke a Lambda function from the Lambda console, from the SDK, software development kit, on the CLI, okay? So function is, Lambda is an event trigger function. You use Lambda configuration. You just have the code, the dependency libraries, execute code, Lambda function, and then execution of the code when it's just triggered, right? Well, probably next Saturday of the next class, I'm going to show you how to stop an instance. I think there's one video that you guys can watch in my channel, right? Go to my channel, right? I think the channel real quick. So you can come here to my channel and then look for that particular, I think is somewhere here. How to stop an instance, using Lambda. So I can come here and give you guys this guide.
You still with me?
So that you can come here and just watch it if you want to. Something that you guys can watch. Stop and start with using CloudWatch, something that guys you can see there, and it's going to teach you how to do it. Some of the uses you can use as well is just, the user uploads a picture to a bucket, and then Lambda will just, with a role, because the role is what allows Lambda to work with this S3, Lambda will create, right, a thumbnail and put it in another bucket. So you're changing the image to a thumbnail and puts it in another bucket. So you have to create a function that does that. Okay? That's one of the uses of Lambda, create a thumbnail. Some of the limits that Lambda has is the function timeout is 15 minutes. So if your application is going to run more than 15 minutes, Lambda is not the service. Okay? So concurrent executions, you can have only 1,000. This is a soft limit. It means that you can have more. Okay? 1,000 at the same time. Okay? Functional layer storage, 75 gigabytes. Hard limits, you cannot change this. The maximum function memory allocation is 3,008 megabytes. Okay? So it's about 1 gigabyte, or 3 gigabytes more or less. Right? The function timeout 15 minutes. If it runs more than 15 minutes, it will time out. Okay? Deployment package size is 250 megabytes on zip, including layers. So if you are uploading the code, it has to be 200 megabytes on zip or less. There are other limits that you can take a look at the AWS Lambda limits documentation. All right. The takeaways here, Lambda serverless computing enables you to build and run applications and services without provisioning or managing services. You can read this later, guys. Okay. This is something that later, guys, you can do. We still have this guy. It's almost 2:35. Well, this guy is for web applications, right? It's a managed service, right? That automatically handles infrastructure provisioning and configuration, deployment, load balancing, automatic scaling, health monitoring, analysis and debugging, logging. All of this you can do with this guy. It's platform as a service. You don't pay for that; it's free. But you may pay for the resources that Elastic Beanstalk creates. Right? It supports these guys: .NET, Java, PHP, Node.js, Python, Ruby, Go, Docker. Right? You load the code, and then it will deploy for you. Right? It deploys in an Apache server, Jinx, Passenger, Puma, whatever server it needs to use to deploy your application, mobile application, or web application. Okay? The only thing that you have to do is write the code. That's it. AWS will do the rest for you. Okay? It's fast and simple, right? It's fast and simple to use. Start using developer productivity. You don't have to worry about so much. If you're the developer, it improves your productivity because you don't have to worry about so many things that you would have to worry if you had a server, like working EC2 or something like that. It's difficult to outgrow because it's super highly scalable. I mean, it's hard to beat Elastic Beanstalk. And you have complete resource control. You have a lab that you can work with AWS Beanstalk. Right. Well, the takeaways here is that, Beanstalk enhances developer productivity, simplifies the process of deploying your application, reduces management complexity. It can use Java, .NET, PHP, Node.js, Python, Ruby, Go, Docker, and there's no charge for Elastic Beanstalk. Okay? Only for the AWS resources that you use. Well, guys, this is what we covered today. Wow, it's a long class, right? 90 slides.
Is that all?
Huh? Is that it?
I think we need another 100.
A lot of information.
Yeah. Guys, but you have 1 week. I mean, before we have the other class, if we have class next Saturday.
Yeah, we have to practice every day.
Yes. So you can read this at home. I don't need to read this for you guys. Okay. So don't forget to do the knowledge check. That's very important. Okay. And we have the little test here. So which AWS service helps developers quickly deploy resources which can make use of different programming languages such as .NET and Java? Come on, they gave you they just gave you the answer before this. What is the key word here is programming languages and developers quickly deploy resources. Someone is giving me an answer in the chat. Let me take a look at the chat. Okay. Well, what is the answer? I mean, the square is in the middle. Which one do you think is the answer? Elastic Beanstalk or EC2?
Elastic.
Okay, good. Good. So I think I'm going to paste this on Slack. Additional resources. Okay. And I would do, before we go, guys, I would do something real quick here. I want to launch an Elastic Beanstalk for you guys to see it real quick. For you guys to see it. So I want to create an environment, right? Create an environment and maybe an application, my MDC application, right? I'm gonna choose the platform. What platform do you want, guys? Docker, not Docker. Java, Node, PHP, Python, Ruby. What do you want? Just give me
Java.
one. Java, okay. Let's create one in Java. Sample application. We're gonna use the application that the code that AWS created, okay? As simple as that. Now it begins to create the environment for me, right? Let us wait for that to, you see, I don't have to do anything. I just upload the code and that's it. It will create everything for me. It will create the Elastic Beanstalk, Amazon S3 storage. It will create the Elastic Load Balancer. In the meantime, we can just do something here. Maybe we can just create another table, maybe, or I don't know. What can we do here? Maybe we can say select now. Okay, I always forget this. So what time is now? It's 2031. 2031. What do you mean 2031? Oh, because this is UTC. UTC is 5 hours from now. Right now it's 1531. Okay, So we're printing this, right? Just waiting for this to happen. Okay. So maybe we can say select, concat, and we say today, date, date is say something like that, you know, or maybe as today's date. Okay. Today's date. Waiting for this to happen, guys. Be patient with Elastic Beanstalk, you know, in its time. So it's so cool to have a server in your virtual machine. I don't know, guys, but I don't know. I find this fascinating. But I can do whatever I want here. I can say select count from users. It's just before 4 users, right? In my account. I maybe have, how many orders do I have? I have 2 orders, right? Okay. Maybe I can say, is this deployment complete? It will show me now a URL very soon. We just have to wait. If I refresh this, I get, well, it just will show it now. Okay. Nine, right? Okay. Okay. So it's coming now. Okay, so it gives me here a URL and then boom, beautiful. That is a Java application with Elastic Beanstalk. Okay.
Excellent.
So guys, you can play with Elastic Beanstalk. I'm gonna come here right away, and delete this, terminate this environment. Okay. I don't want to be charged for anything. Okay. Terminate it. And the application will be, well, probably doesn't let me delete the application until I delete the environment. Okay. But I can do this. And then, all right, it's been deleted. Good. So guys, do you have any questions before we go?
No.
No?
Thank you.
You do? Go ahead.
No, thanks.